My name is Shinnosuke from the University of Tokyo, and I will present with Kohei Kajikawa, is also from the University of Tokyo. And our presentation is titled Formalizing Argument Structures with Combinatory Categorial Grammar. Combinatory categorial grammar, or CCG, as most of you should know, is a highly lexicalized theory of grammar that views syntactic derivations as directed type inference. And one advantage of the formalism, which is also the reason why we employ it in the current study, is it is performance compatible. It allows to a large extent left to right structure building and can therefore be embedded in a model of real-time human sentence processing as we do right now. It thus conforms to the strict competence hypothesis, which states that competence grammar is sufficient to provide structures that are used in real-time processing. This is an example of left to right analysis of a Japanese SOV sentence. John ga cabin koatsu, John breaks the vase. As you can see, the subject and the object can be composed into one structure, one single constituent before the verb appears. And there is some psycholinguistic evidence that this kind of free-verb composition actually takes place in our brain. And CCG can capture that observation. However, one question that we'd like to raise today is where the argument structure information should be located. In typical CCG analysis, the argument structure is encoded in the verb's lexical entry. For example, koasu break should be specified as S/P/P, meaning that it requires two NP arguments to its left. This analysis resembles that of so-called projectionist analysis in Chomsky generative grammar, for example, in the government finding framework in Chomsky 1981, in which koasu would be associated with a list of arguments with particular thematic roles like agent and patient. And in a projectionist analysis, the argument structure is then projected to the verbal phrase. However, there is an alternative popular analysis of argument structure today called the constructivist analysis. This is how a typical constructivist analysis looks like. The verb koasu is decomposed into a root here and functional heads. And the root itself does not have any lexical argument structure. And instead, arguments are introduced by these functional heads. For example, the little V head introduces the internal argument, while the active voice head introduces the external argument shown here. And these functional heads also assign the thematic roles, agent and patient, to these heads. Oh, sorry, yeah, that's the explanation of that. And a variety of facts have been argued to provide support for constructivism. One representative fact is the availability of novel argument structures. In these sentences, the word siren is used as a verb in a variety of argument structure constructions, although the word siren is typically used as a noun. Native speakers of English can interpret these sentences even if they have never heard of siren being used in these particular constructions. And this is kind of unexpected if the verb argument structure has to be lexically specified, while constructivism can offer explanation for this by syntactically composing the argument structure and assigning thematic roles to them. Another fact in support of constructivism is that there is a systematic correspondence between syntactic positions and thematic roles. The generalization itself is well known and often dubbed as Utah or uniformity of theta assignment hypothesis, but constructivism can provide an explanation for that in terms of the hierarchical organization of functional heads. Constructivism is often couched in terms of distributed morphology, which itself is based on minimalism. The formalism is characterized by bottom-up structure building and late insertion. Late insertion means that the phonological and semantic interpretation of the structure is determined after the syntactic structure is built. For example, in this tree is built in narrow syntax, but there's no semantic or phonological information yet. And there are a set of insertion rules like this, which dictates how these nodes are semantically and phonologically interpreted. For example, the active voice head here should be pronounced as S in the presence of break root, and that is dictated by, okay, the Morse calls it a bit slow, but yeah, and this is dictated by this rule, particular rule. So late insertion can look at the syntactic environment that has been already built, and this offers an account for why particular node can be pronounced differently depending on context. In this case, the active voice tag should be pronounced differently depending on the root. However, this kind of bottom-up structure building plus late insertion can be problematic when performance is taken into account. As I mentioned before, real-time sentence processing should proceed from left to right. You won't wait until the entire syntactic structure is built to get the interpretation. And we should care about compatibility with performance, since there is some psycholinguistic evidence that verb-argument separation matters for real-time sentence processing. I don't have time to review all of them, but there is some evidence. And this is the primary motivation of the current study. We ask whether constructivist analysis can be formalized in CCG, which is a grammar formalism that is argued to be performance compatible. So in the current study, we use Japanese verbal domain as the test case, since it has transitive ordination paradigm that is morphologically visible. So in the next part, we first discuss how the Japanese verbal conjugation can be formalized in CCG, and then build on that analysis, develop an analysis of the transitive ordination in the third part. Okay, so please.
So, this is the overview of the Japanese verb conjugation paradigm. As you can see here, the conjugated form consists of the stem and some inflectional ending. And the stems are not always, not entirely stable, as you can see here, for example, TON here. We will discuss how to deal with it later. 2010 proposes a model-based analysis of Japanese conjugation in CCG. In his analysis, the combination of stems and inflection endings is dictated by features. His analysis is very useful to the application to the corpus data because Japanese orthography is more based. On the other hand, a segment-based analysis we propose here looks like this. It can extract a common segment found within morals, for example, A here. However, it cannot explain the fact that the stem TOB changes to TON when combined with some past tense morpheme, for example, from over to from down. So this is captured by further decomposing stems into two parts. So the category of the former part, TO, means that it requires inflection constant to its right. Then we can make N override the requirement to get string TON. This the same analysis can be applied to the other types of phonological changes by Kaku to Kaita and Yom to Yonder. In monogrid conjugation, our analysis is the same as the model-based one because morpheme boundaries of a segment-based analysis do not differ from the morpheme boundaries of model-based analysis. And even in the irregular conjugation, our analysis can extract a common segment K from a stem or like this. And then we will move on to the next topic from Shinnosuke again.
So now we move on to the analysis of transcript automation in Japanese, where the constructivism, as we introduced earlier in the first section, matters. So Japanese has many pairs of transitive and intransitive verbs, and they share a root. For example, have in the first row, while their transitivity is marked by the morpheme that follows it. This paradigm has no specific direction. It's neither exclusively transitivization or intransitivization. And most importantly, for the current purpose, the alternation morphemes are conditioned by the root. For example, the transitivity morpheme is a after ak or han, but s after or ama or koa or a, etc. So, and several studies have analyzed this alternation in distributed morphology. We particularly based our analysis on Oseki 2017. And according to these analyses, the transitivity morpheme is the realization of a voice head, which is the external argument, with different flavors. In the case of koa break, the active voice head is realized as S and introduces the external argument, as you can see in the left tree, while the non-active voice head is realized as rare and does not introduce an external argument, as you can see on the right. Importantly, this analysis captures the fact that the vase broke implies John broke the vase, as one of the reviewers pointed out. So the shared meaning is represented by this little v phrase. This part is saying both trees. And so you can see the implication relation between these two. And actually, this analysis can be rather easily translated to CCG. This is our analysis of koasu, transitive. The root of koa is the leftmost element. It is categorized as R, and it is also annotated with the Roman numeral 6, which indicates that this element belongs to the class 6 of the transitive alternation paradigm. And this element is then selected by the element in the middle, which corresponds to the label we had in the distributed morphology analysis. And importantly, the class feature must be inherited to this entire constituent by the variable 1. And then this verb base is selected by the rightmost element, which is the active voice set. And the active voice set also introduces the external arguments. Very similar analysis can be applied to the intransitive structure, koareru. So the first two parts is exactly the same. And then the non-active voice set, which is pronounced as rare, selects the appropriate verbal base. So as you can see, allomorphs, the different pronunciations of the same note, cannot be inserted late in the current approach, unlike in the distributed morphology, because the derivation should begin from the exact surface string in this kind of approach, because we are modeling the process, the real-time processing. We should start from the observed string, so we cannot insert late in the interpretation. Instead, the allomorphy is realized by selection of appropriate Saussurean morpheme, the sound meaning pair, by features. And in order to do that, we need lexical items with that same denotations to achieve this. For example, we need a series of lexical items that corresponds to the active voice set. So these has differ in the pronunciation and the class specification, but they have exactly the same denotations. There is some way to write this more, compact in a compact way, but we skip that. It's just technical thing. However, one may ask, okay, so anyway, so feature inheritance is necessary to account for the contextual allomorphy in transitive automation, because you have to make the root feature to be inherited to the next level. But one might wonder that if it wouldn't be problematic for the observation that there are some locality constraints on contextual allomorphy. In distributed morphology, it has been said that quote, only material within a spell domain defined by phase heads would be visible as context for vocabulary insertion. This is a bit technical statement, but basically, it means that the contextual homomorphism can only be able to look at some local context, which is typically defined by phase in distributed morphology. And for example, in Japanese, verbs can be formed by attaching n morpheme to adjectival stems. For example, fukamaru, fukameru, tsuyomeru, tsuyomaru, tatamaru, tatameru. And they all show the same translated ordination pattern. So it seems like the presence of n blocks the inheritance of the feature on fuka or tsuyo. So the ordination pattern cannot be sensitive to the particular adjectival stem. And if feature inheritance is unrestricted, this insensitivity to non-local context cannot be explained. A solution to this problem that we propose here is that there is a principle that features must be morphologically or semantically motivated. Actually, a similar proposal has been made by Steelman as principle of category type transparency, which says that categories must be semantically motivated. Features and our roots are purely morphological and not semantic. So we propose a revised version of the principle of categorical type transparency, which says that the features of a given constituent must be motivated by its morphology or semantics. This means that the morphologically null element can inherit the morphological feature of its daughter. For example, the feature of koa can be inherited to the koa plus null element because the second element is null. While when the second element is visible, for example, m, then the entire element is different from the fuka, and therefore the feature of fuka cannot be inherited to fuka. So in conclusion, we propose a formalization of the constructivist analysis of argument structure in C2G, which provides basis for models of argument structure processing. This is my personal background. So I basically do research on sentence processing and psycholinguistics, but I need a form of system that can account for how actually we build structures to interpret the argument structure. And that is why we focused on CCG, but while also integrating the some knowledge from distributed morphology. And we also argued that it provides a principle of explanation for the locality of contextual allomorphy based on the locality of selection. So now contextual allomorphy is just reduced to selection at the cost of more probably a bit larger lexicon. Okay, there are many questions that are really left, but one question that was raised by both of our reviewers is how to constrain argument structures that can be combined with a given root. This is particularly problematic when verbs that do not contain a transitive morpheme are considered. For example, keru, ket, does not contain such a morpheme, but allows only transitive use. And one solution to this problem is to annotate roots with features like plus transitive and make the active voice head select this feature, while non-active voice head should be incompatible with this feature. One reviewer, however, suggested that this would be just a notational variant of S backslash and B backslash B. Maybe. But one possible pathway to the answer to this question may involve the analysis of nominalization, for example, tabekata, manner of eating, because kata seems to attach to verb stem of any argument structure. Tabekata, arukikata, the manner of walking, or kowashikata, the manner of breaking, kowarekata, the manner of disrupting or breaking. But of course, there are some problems that should be overcome to adopt this analysis. So anyway, yeah, and also, okay, I have 1 minute left. So also, we have not provided an explanation for the elsewhere principle in contextuality. We may also investigate how processing with so many empty categories can be actually implemented as a model of inference processing. It seems that there would be a lot of ambiguities involved in that kind of analysis, but given that competence analysis of competence grammar seems to suggest the presence of such empty categories, I think we should pursue that direction somehow. Thank you.
Any questions from the floor or anyone attending on the Zoom? Okay, can you come to the front?
I'm wondering if your CCG analysis of phonology is maybe taking a little bit too far. For example, I mean, well, you talked about tombo, right? For example, consider combini or computer, right? So pronounce written N, right? So its spelling is N, and you can analyze an N, but it's just pronunciation. But I mean, we know we actually reminded today that, for example, ta was used to be a auxiliary verb, right? So tombo was like tobu ta. So it's essentially that's how it was spelled originally, and then just pronunciation changed it, but it was spelled tobu ta, but it was hard to pronounce it, pronounced tonda, and later on spelling adjust to match the pronunciation. But morphology was originally, I mean, I know tobu B was like that. So it was just a sound changes because of the, well, constraint of the human pronunciation system, right? And therefore it's kind of seems to be ought to me analyzed the same way as morphology. So maybe the sound, for example, if you're parsing, maybe undo the sound changing and say, well, it's actually initially was spelled tobu ta, and I mean, well, pronunciation is pronounced differently, but that's what's original spelling. And parsing based analysis based on kind of idealized spelling, morphological spelling.
Okay, thank you. So yeah, you're right in saying that tonda is originally togda, and there is some historical change involved in being togda being tonda. But so one answer to the question is that in the mind of contemporary speaker of contemporary Japanese, I'm not sure if we actually analyze tonda as togda. And we every time we do it says we compute from togda to tonda, and so yeah.
Maybe then I would have a, I mean, I don't know. Maybe like my question disappeared. I mean, if you answer this. So maybe that one thing that I wasn't clear, but now, I mean, what you said. So what the motivation here? So did you, I mean, I know, so-called build an effective theory or build a foundational theory? So foundational theory, how things really are and how we understand. And effective is just, well, we have this some phenomena, we need to kind of approximate, describe it, and make prediction. So we don't actually, I mean, in effective theory, we don't care that these are the true things. I mean, true maybe doesn't even apply. You just describing things. So we don't care about what's the, I mean, underlying, what's the fundamental principle. We just want to describe phenomena and make predictions. So if you take the effective account, then I fully agree that I withdraw the question, because indeed, I mean, we just, I mean, we don't, I mean, I don't know. It's not even a question of analyzing how this came about and how morphology. We just wanted to build a theory to explain phenomena in the most kind of, I mean, nicest, parsimonious, whatever way that we choose.
Yeah, I'm not sure if I have fully understood your distinction between effective and fundamental theory. But the primary motivation of the current study is to write down the basis for maybe effective theory of sentence processing, and we want to capture the fact that for one thing, we know that tonda and tobu is the different forms of the same verb, and we know that in our mind, and also we can analyze these different forms in real-time processing, and we can, for example, infer that tobu and tonda are the same kind of event. So maybe it's effective theory.
Yeah, okay. So in that case, yeah, I mean, I know, then whatever, I mean, an effective theory, then whatever works, so that you can't actually criticize it. I can criticize why you choose this form, because this approach, because it just works.
So I think that if for this to be a fundamental theory, you need to account for why B corresponds to N. Do you mean that?
Yeah, so well, but this is kind of a separate layer, right? So you build a separate layer, so you build a theory of phonology based on human vocalization apparatus, right? And then you apply the theory, it's a separate layer. And then you undo the layer, underneath there is a kind of different layer, how things in our mind, I mean, morphological layer, right? Which is probably unrelated to phonology, right? Because phonology is independent So in our mind, you can think we make idealized spelling, and then with the way we kind of I mean, how we manage to pronounce it, right?
Yeah, well, I kind of doubt if it's possible to give a fundamental theory if we just consider the competent theory of the competence grammar of contemporary Japanese speakers, because the correspondence between the final consonant in the stem and the euphonic form is quite strange. And V and N corresponds to N, K corresponds to I. Well, there is.
Yeah, but I mean, for example, the gaining, for example, right? So it's gaining. For example, it's written, so it should be, how if you spell it in furigana, right, it should be N, but it's not pronounced, this way, right? So if you already know that there is adjustment between spelling and pronunciation, there is English, then there is a lot of things, right? That's.
That's one very interesting. Yeah, I'll think about it. Thank you.
Okay, thanks for the talk. The derivations that you were showing were all using just the application rule of CCG.
Application and combination, composition.
So now I was wondering, because the categories that you have are much richer than, say, the bare CCG categories, whether your approach would throw some light on the fact that Japanese, as far as I'm aware, has a certain word order freedom, in the sense that the verb will be final, but that there is a certain freedom in how the arguments of this verb will actually be structured. So is there anything in your more refined category theory that would throw light on that, on the possibilities and the impossibilities of that and scrambling?
So I'm just suggesting that we may need more maybe some different categories for to account for the scrambling word order. Actually, Professor Becky has written a book on how to analyze the scrambling in Japanese, and I believe the basic approach is just maintain the basic word order as we show here, and then assume some new rules to account for the scrambled word order. So basically we follow that approach. So
but would these new rules, would they be sensitive to the category refinement that you are introducing here in your
we haven't considered that very well, but yeah, so but basically the point is that once we've done with these kind of composition, basically the result is basically the same as what Beck-san has established. So we assume that there is not so much problem with connecting this theory into the more larger syntactic theory that has been proposed.
Okay, thank you.
Thank you very much.
Okay, there's a question from Sumio Nishiguchi. Go ahead.
Yeah, thank you for the talk. I was looking at the example number 3 in the proceedings. So you assign the event to break, and that the agent argument is introduced by the causative, right?
Yes.
Yeah. So I was wondering what happens with like an accusative, like the base breaks. So kabin wa kowareru. So where does the theme come from? Does it come from reru?
No, in our current analysis, which basically just follows the analysis of the distributed morphology. So maybe let's begin with the distributed morphology analysis, according to which the internal argument is always introduced by the below the head, which is also present in the translated structure, and that captures the implicational relationship between the two. So we simply follow that analysis, and the internal argument is always introduced by the phonological null element in the middle. So you can see the backslash and P in the middle, and that is where the theme is introduced. But one question is then why do we need the re? But our current assumption is just for the morphological features. So we have to turn the base into a stem, and that is why re is needed. But this is kind of stipulative, so maybe there is some deeper reason for that.
I see. So there's a category for the no morpheme. I see. Thanks.
Yeah, no, yes. Thank you.
Any other quick comments or questions? Okay, I think it's about to stop. Okay, thank you very much.
Thank you very much.